Hey everybody, we're working on section 6.4 today. Got a couple new things coming at you, but I don't think it's going to be too hard for you. Take good notes. We're going to learn a couple new ideas. Rhombuses and rectangles and squares. You're probably a little bit familiar with those. So we're going to look at classifying them using the properties of the diagonals and that sort of thing to learn a couple new things about those particular shapes. Now, let's talk about what those are. Little review. We're still on our parallelogram kick, okay? Rhombuses, rectangles, and squares are all parallelograms. Now remember, a parallelogram is a quadrilateral with both pairs of opposite sides being parallel. So if a rhombus is a parallelogram, well, we know both pairs of opposite sides are parallel. Same with rectangles, same with squares, because all of these three new terms come with the definition that they are all parallelograms. All right, to review parallelograms really fast, here's parallelogram ABCD, and we remember a few theorems from the other day. 1, it's a parallelogram, opposite sides have to be congruent. Next, angles, consecutive angles like C and D, or, for example, like C and B, any two consecutive angles next to each other, they have to add up to 180. All right? Also, any opposite angles, like C and A, have to be congruent, as do B and D. Remember that? All right, remember that. Then, finally, all parallelograms, diagonals bisect each other, cut each other in half. Okay, so those things we learned the other day about all parallelograms. Now let's talk about some special parallelograms. Rhombuses, rectangles, and squares. All right, a rhombus is a parallelogram with 4 congruent sides. Good? And a rectangle is a parallelogram with 4 congruent angles. Good? And of course, since they have to add up to 360, we know they all have to be 90-degree angles. And a square, the reason I got it here in the middle, and I've got the whole thing shaded differently, all right, a square is both a rhombus and a rectangle. It has both congruent sides, all 4 of them, like a rhombus, and 4 90-degree angles, just like a rectangle. So a square is a combination of both a rhombus and a rectangle. Got it? Okay, so what do we know? Theorem 613. If we have a rhombus, so you'll see we got it marked here with parallelogram, perpendicular or congruent sides. If it is a rhombus, then its diagonals must be perpendicular. Good. If it's a rhombus, diagonals are perpendicular. Fair enough? Let's go. If it is a rhombus, then each of the diagonals bisects a pair of opposite angles. In other words, the diagonals bisect B and D, which means 1 is congruent to 2, 6 is congruent to 5. The other diagonal bisects A and C, which means it splits those into congruent halves. And you know what? Going back over here, since opposite angles are congruent, well, if we knew those angles are congruent in the first place, right, that C was congruent to A, and they're both bisected, well then, you know what? 3 and 4 must be congruent to 7 and 8, and same argument over here, all 4 of these must be congruent. Let me clear all annotations. Okay, here's the argument again. If B and D had to be congruent in the first place because it was a parallelogram and opposite angles of parallelograms are congruent, then we cut them both in half. Well, not only is 1 congruent to 2, but 1 is congruent to 2, and they are all congruent to 5 and 6. So these pairs, all right, for a rhombus, we not only split the opposite angles in half, but we create 2 sets of congruent pairs of 4, pairs of 2. All right, couple practice problems. You know how it works. Pause, and when you're ready, here come the answers. Here we go. Find the measure of the number of angles. Well, let's see. First of all, we know it's a rhombus. That was given. Now it tells us the diagonals are perpendicular. Therefore, measure of angle 1 equals 90. Since the two lines here in question, AB and CD, have to be parallel. They're cut by, do that one, cut by this transversal. Well, what do we have here? We have alternate interior angles. Good. Oops. Okay, 1 must be 90. Since these are alternate interior angles, 2 must be 58. Since the diagonals bisect the angles, by Theorem 614, since the diagonals bisect the opposite angles, 2 must be congruent to 3, or both of them must be 58. And then when you use the 3 angles, here, here, and here, must add up to 180, we can figure out what 4 would be. Okay, follow that along if you have to. Hope that makes sense. And let's move on. Next question. ABC is a rhombus. Find the measure of the numbered angles. Pause. Answer coming. All right, there's a bunch of ways we can do this one. Pretty simple though. Okay, we know it's a rhombus, therefore it's a parallelogram. Parallelogram says that by Theorem 6.4, consecutive angles are supplementary, or these two must add up to 180. Same with these two. So those two must add up to 180. Then measure BAD. Plus B. Sorry, BAD. Yeah. So measure of angle BAD, this one, plus B must be 180. BAD must be 76. And since this is cut in half by a diagonal, 1 and 2 must be 38. Over here, we make the same argument with angle B and angle BCD. All right. And again, we've said that all these must be congruent by the definition of parallelogram and by the definition of rhombus by the couple of theorems that we've talked about. Okay. First out of the way, so you can look at them again if you need. Now, a second way we might have done that, by the way, as I looked at it, I know that we have isosceles triangles because these sides have to be congruent, right? And if isosceles triangles, then we must have base angles being congruent. 1 must be congruent to 3. Same over here. Sides are congruent. 2 must be congruent to 4. All right. In general, we could have solved this the way we did a couple chapters ago by looking at base angles of isosceles triangles as well. Remembering, of course, that if this is 104, opposite angles of any parallelogram also have to be 104. A couple ways to do that one. Finally, new theorem, 615. If a parallelogram is a rectangle, all right, 4 congruent angles, then its diagonals must be congruent. Here's the kind of problem that goes with that. Pause. Answer coming. Yeah, pretty easy. We're going to set those two lengths of diagonals equal to one another. PR is this, QS is that. They must be congruent. So here's our theorem, or here's our equation. And we find out that x is 9. It's not what the question asked. We plug in x is 9, so we find out that the two diagonals must be 33 units long. Okay, but to find ST, which is what the question's asking, all right, now we remember for any parallelogram, the diagonal is bisected. So if that whole thing is 33, we cut it in half, and we find out that ST must be 16.5. Good. Putting it all together, summary sheets. Next 3 pages, you might just want to make a little important note of this. All right, rhombuses have all the properties of all parallelograms. So those theorems apply, and we know that opposite sides are congruent. Well, duh, opposite sides in all of the, I'm sorry, for a rhombus, all 4 sides are congruent, so obviously opposite sides are congruent. Anyway, but also consecutive angles are supplementary. Those will add up to 180. So will those. Okay, opposite angles are congruent. check, and check, and diagonals will bisect each other. Diagonal, diagonal, they cut each other into halves. But particular to rhombuses, diagonals are perpendicular, right? And each diagonal makes sets of congruent opposite angles bisected. Okay? Rectangles, like all parallelograms, same things are true, but then in addition, diagonals are congruent. And look back at the other diagrams if you need them to be prettier than I've got them here. But, okay, rhombuses, all parallelograms plus a couple others. Rectangles, properties of all parallelograms plus another one. Squares have properties of all parallelograms and all rhombuses and all rectangles. So all of those things we've talked about just now apply to squares. All right, so let me make this one a little bit prettier. Okay, diagonals are both congruent and both congruent. All four of these are the same. They are perpendicular, which means all four of these are the same. They bisect angles, which means all of these up here. Every one of these halves is 45. All right, so important things to know. I'll let you get them in your notes. We'll work on it tomorrow.